So in this video, we're going to use the power rule to find the equation of a tangent line. So it says find the equation of the line that is tangent to f of x equals the square root of x when x equals 4, and then do the same thing again for x equal to 5. So in a picture, what we're needing to do is to find the equation of this line right here. We have the graph of f of x, the square root function, and on that graph when x equals 4, if I calculate f of 4, I get the square root of 4 equals 2. So the ordered pair 4, 2 is on the graph of f of x, and at that point on the graph there is a line that is tangent to the graph. So we need that line, and we know that the equation of a tangent line, I'll use big T for tangent line, has the form mx plus b, where m is the slope of the line. So we're going to need to find the derivative of f of x, because the derivative of a function tells us the slopes of the tangent lines to that function. So I've found the point on the line, the point 4, 2. I have a function f of x equals the square root of x. I want to recognize that this is the same as x to the 1/2. So this is a function that has the form x to the a. So to find the derivative f prime of x, which is just equal to d dx, that's a horrible dx, d dx, take the derivative of, this operator says take the derivative of the thing that comes next, x to the 1/2. I can use the power rule to calculate this derivative. So the power rule says take the exponent and bring it down into the coefficient position on x, and then subtract 1 from the exponent. So 1/2 minus 1 is negative 1/2, which is the same as 1 over 2 times x to the, bring the x down into the denominator. I can make that exponent positive. So x to the positive 1/2, and I could write it in radical form as 1 over 2 times the square root of x. So the slope of this tangent line to the graph when x is equal to 4, the slope of it's just going to be f prime of 4, because the x value we're working at is x equal to 4. So to calculate f prime of 4, we just pop our 4 into the derivative. So I get 2 times the square root of 4, which is just equal to 1 over 2 times the square root of 4 is 2. So stepping up here, I see that f prime of 4 is equal to 1/4. So the tangent line is going to equal, it's mx plus b, but m is the slope of the line. 1/4 is the slope of this line, so it's 1/4 x plus b. And I've already calculated this point on the line, so I use that to figure out what b is. So plug in the when the output is 2, 1/4 times the input is 4 plus b. So 1/4 of 4 is 1. I get 2 equals 1 plus b, and then subtracting 1 from both sides, I get 1 equals b. So that's the location of the y-intercept. And I want to update my tangent line formula. So tangent line is equal to 1/4 x plus the y-intercept is 1, and the picture is actually verifying that y-intercept of 1 for us. So this is the equation of the line that is tangent to f of x when x is equal to 4. Then it says do the same thing again for x equal to 5, and this is primarily here to remind us that numbers don't always need to work out nicely. I would need to find the point on the graph of f of x when x equals 5. So to do that, I would just calculate f of 5, which equals the square root of x, but I'm replacing x with 5, so the square root of 5. So the ordered pair on the graph would be input 5, output square root of 5. The line that's tangent to the graph at this point will have a slope given by the derivative evaluated at 5. So f prime of 5 is equal to 1 over 2 times, it's the derivative right here was 1 over 2 times the square root of x. So it's 1 over 2 times the square root of 5. And I could rationalize this if I wanted to. I could rationalize the denominator by multiplying by root 5 over root 5. If I do that, I get 1 times the square root of 5 in the numerator over root 5 times root 5 is 5, and 5 times 2 is 10. I get 10 in the denominator. So my tangent line formula is still going to be tangent line is equal to the slope times x plus b, or the y-intercept. So the tangent line is still going to equal the slope of the line, which is the square root of 5 over 10 times x plus b. And then I plug in the point on the line to find b. So the output is the square root of 5. When the input is 5, so pop my input of 5 in, and 5 will go into 10 2 times, so I get the square root of 5 is equal to the square root of 5 over 2. So I'll step my work up here. I'm going to need to subtract the square root of 5 over 2 from both sides to get the b by itself. So the square root of 5 minus the square root of 5 over 2 equals b. And to do the subtraction, you need a common denominator. So you would multiply by 2 over 2, which will equal b. That will give us a denominator of 2. And we wind up with the numerator 2 roots of 5 minus a root of 5. So 2 roots of 5 minus 1 root of 5 is just a single root of 5. All over 2 equals the y-intercept. And then we can update our tangent line formula. So the tangent line at the point 5 square root of 5 is going to be given by the square root of 5 over 10 times x plus b, but b is just the square root of 5 over 2.